Hey there, science students. We're ready for our first video. Here we go. Introduction to the solar system is what chapter 1 is called. So there were different theories over the years because, it's been a long time. So the first one, and the one that held the longest, was that Earth is at the center. We call that geocentric. Geo for Earth, centric for center. Duh. So that was put forth by a guy named Claudius Ptolemy. Yes, it starts with a P, but the P is silent. So his name is Ptolemy. And his theory is called the Ptolemaic theory. And it says that the Earth is at the center of the universe. Okay? Now that was about 140 CE. It took until about the 1500s for someone to put forth a new theory. And he did that. The guy put it forth just before he died. Because by that time it had been so ingrained in society that if you said something other than the Earth is the center of the universe, you would have been considered the most vile creature, and that you were going against God, and you were a heretic, and you were just evil or something, and they'd put you in jail, and it was weird. So about 1500 years after Ptolemy, this guy named Nicholas Copernicus put forth his theory, and we call it, of course, the Copernican theory. And his is heliocentric. Helio for sun. So he says the sun is at the center of the universe. And then not long after that, because someone invented this wonderful invention called the telescope. And no, it was not Galileo. He did not invent the telescope. No. Someone else did. But it's not going to be in the test, so don't worry about it. But Galileo took that invention and used it and made lots of discoveries. He found 4 moons on Jupiter, and craters and mountains on the moon, and sunspots. He also proved, when we see the planets in the sky, with our naked eye, it looks like they're stars that are moving. So they were always called wandering stars. With the telescope, he could prove, no, those are not stars. Those are planets. Ding! So, yay on you. Now, looking at planets, in our solar system, we now know that we have 8 planets, 5 dwarf planets, and there are more than 165 moons total, plus so much more. And the sun is not the center of the universe, just the center of our solar system. So things have shifted even still. That's the nature of science. The more you know, the more specific you can be, the more accurate you can be. If we didn't keep checking our data, we'd still think that the Earth was the center of the universe and that it was flat. Okay? Now, why is Pluto not a planet? I learned it was a planet. Yes, you did. Okay, when Pluto was discovered in 1930, it was labeled our 9th planet. Woohoo! And then in 2006, the astronomers... There's my yawn. I've been pushing it back. In 2006, the astronomers decided, we got to make some rules here. What's a planet and what's not? Because we're finding all these things, and we can't call them all planets. So, planet has to orbit a star, be big enough that its own gravity causes it to be round-ish, be small enough that it isn't a star itself. Doesn't make sense to me, but... And it has to have cleared the area of its orbit of smaller objects. So those are the 4 things that they look at. Does it orbit a star? Check. Is it big enough that the gravity that it has makes it round-ish? And is it still small enough that it isn't a star itself? It doesn't have other things, like other planets orbiting it. And has it cleared the area of its orbit? So in other words, as it goes, there aren't smaller objects in its orbit. It's pulled them into its orbit. Now, then they said, of these four, if the first three are true, but not the fourth, then it's a dwarf planet. So if it still has stuff in its orbit that it hasn't cleared, then it's a dwarf planet. Okay, so we have 5. Besides Pluto, we have Eris, Ceres, Makemake, and Haumea. Oh my goodness. I guess I shouldn't do these videos first thing in the morning, huh? Good morning. So, let's look at the shape and size of orbits, all right? Now, distances in the solar system are used, we measure them in something called astronomical unit, okay? Because if we use kilometers, we'd be having like all these zeros. We'd be talking about billion and quadrillion and googleillion, and so we just something in my eye, sorry. We use something called an astronomical unit. Basically, the scientists said the distance from the sun to the earth, that's what we'll call 1 AU, 1 astronomical unit. So it's about 93 million miles or 150 million kilometers. Now, not all planets rotate the same or revolve the same. So look at page 5. You're now allowed to go in the hallway. Look at page 5 and check table 1.2. It's really, really interesting. It shows you the time of a day and a year measured as if it were in Earth time and year. Okay? So some are, really look at Venus. Venus is cool. And I'm not going to tell you why. You're going to have to tell me why. Yep. Okay. The role of gravity. Sir Isaac Newton, the guy with the apple, said, "Ooh, gravity." Okay, he explained why objects in space revolve in the manner that we see. He came up with laws of gravity. And gravity, by the way, is a force that attracts a body towards the center of the earth or attracts any other body having physical mass. Basically, anything that has mass has gravity or has a gravitational force. The bigger the object, the more gravitational force. Okay? Every object is attracted to every other object by gravity. So the force of gravity depends on 2 things. As I said, the mass of the objects, how big are they, and how far apart the objects are. So the sun is the most massive thing in our solar system. So that's why everything goes around the sun, because it's sucking everybody in with its gravitational pull. Okay? The closer planets are smaller, the further away are larger, so they're still hooked, but they can be further away. Extrasolar planets. A solar system has 1 or more planets orbiting 1 or more stars. Ooh, that would be cool. A couple of different stars that you're rotating. We call these extrasolar planets or exoplanets, and then we only use that because they're orbiting a sun that's not ours. So extrasolar, exo, it's outside. Exo means outside, just so you know. And as of June of 2013, 891 exoplanets have been found. We are not alone. Or at least there's more planets out there. Okay, now, scientists think that the solar system formed from a big cloud of gas and dust called a nebula. Yes, a big giant cloud of gas and dust is a nebula. And so, since they believe that the solar system was formed that way, it's called the solar nebula theory. So, basically the sun would have been the first object to form in the solar system, and then gravity pulled everything to the center while density and pressure just really continued to increase. And nuclear fusion, you're going to hear that whenever you talk about stars. Nuclear fusion, not fission, fusion. Star, our sun, is made of hydrogen and helium. In 8th grade, you're going to find out that hydrogen is the number one thing on the periodic table. That means it has 1 proton and 1 electron. Helium is number 2. It has 2 protons and 2 electrons. So when hydrogen plus the hydrogen combines and makes a number 2, you get helium, but a whole lot of nuclear energy. Okay? And this is something that our scientists keep trying to do safely. That's the end of chapter 1, guys. Yeah, that's the end of chapter 1. So, go to Jupiter, click on Tests and Assignments, answer the questions for Astronomy 1. Okay, and these are the questions that are in your text called Lesson Review Questions. It's on page 7 of your scroll. Remember that you have until Friday, plenty of time, to go to Jupiter and do that. So, I bid you adieu. Return to me with joy and honor.